Hello, I'm Michael Woods, Chief Scientist at the Asian Turfgrass Center, and I have recently updated the OM246 reports to add some tables with supplementary information at the end of those reports. And I want to show what these are. Now, this is primarily a video that is meant for ATC's soil testing clients. So if you are one of our clients from around the world who has done OM246 testing, or if you're one of our potential clients who might be doing some of this testing in the future, you can see what you'll be looking at on your next OM246 soil test report. Now, this might also be of interest if you're doing this type of total organic material testing at a different laboratory but not getting your reports from ATC. And it might also be interesting for you if you're thinking about doing some of this type of testing from anywhere in the world. And it turns out that this type of total organic material testing that I call OM246 is something that is really useful. A lot of people can find this really useful, and I'll show you on the report and try to explain why I think it is so useful, because you're measuring something that is directly related to the amount of sand that's been applied, and you're measuring something that's directly related to how the grass is growing, and it's directly related to the effect of the work that you are doing. And so the way that I put this information on the reports is something that I've spent a lot of time working on this and developing the code to generate these reports, and I think it's really awesome to be able to look at the reports in this way. So I will jump into it and show you. Now, this particular chart is something that I've described before. I made a video and I will put it up in the corner of the screen. I'll put a link to a previous video, and I'll also put that in the show description, where you can see that video, and I walk you through step by step what each of these charts is showing. So these are not new. This is something that I've been showing for 2 years or so on the reports, and I'm going to quickly describe it here and then jump to the tables, which are something new. I think it's really important to look at the change in time of the total organic material. So when you're measuring the total organic material by depth in the soil, I like to see how it changes over time. If you look at how it's changing over time, that is going to tell you if the total organic material is accumulating in the soil, if it's staying the same, or if it is going down. And if it is going down, that means that the amount of sand you're applying or the organic matter decomposition is exceeding the accumulation rate, and so you are causing a decrease. Now, in this case, I'm showing examples from a course that I am calling, what am I calling this? Imaginary Hills Country Club. Okay, I'm calling this Imaginary Hills Country Club, and if we look at this chart here on the left, it says it's a total organic material time series from 0 to 2 centimeters. That's from 0 to 0.8 inches, so it's a little bit less than an inch. These are bent POA grains, and on the charts, the green dashed line is showing the average of all of the database bent POA grains. So we're comparing here, we're directly comparing to putting greens of the same species at the same depth. These are a little bit below average for that particular species. So that's good. But you can also see that from autumn of 2021 to autumn of 2022, the total organic material at the surface went up from 6.1% to 7.8%. So it's really easy to look at that number and look at that change over time and be able to see that the amount of sand top dressing that was applied during that year from autumn 2021 to autumn 2022 was not enough to keep the organic material constant at that depth. If we look just a little bit deeper in the soil to a 2 to 4 centimeter depth or to a 4 to 6 centimeter depth, we see that it's just a slight increase, 3.2 to 3.4 at the 2 to 4 centimeter depth, and at the 4 to 6 centimeter depth, it's a slight increase from 2.3 to 2.6. That is a very minor increase. So it seems that most of the accumulation is happening here at Imaginary Hills in this particular year, right at the surface. I wouldn't be too concerned with getting organic material removed or getting sand applied deeper in the soil, and I would be more concerned with getting sand right into the canopy at the surface, basically in the top 2 centimeters of the soil. And then the next chart makes a direct comparison to all the bent POA greens in the database, and here we can see that this particular result of 7.8%, you can see that the average here was 7.8% on this date, and if we take that and compare it to all the bent POA greens, that is a 40% in the 40th percentile. So 40% of the samples are below this, and 60% of the other samples are above this. So this type of chart and these type of numbers would give you an idea of how your results compare to other greens of that particular species. And the next chart shows a scatter plot of different depths. And again, that other video that I've made, it goes through all of these charts in even more discussion time. So you can watch that and get an idea. And if you really like this kind of stuff and want me to explain more about the OM246 testing, please let me know and I will be happy to do so. And so this scatter plot is showing for the 0 to 2 centimeter depth, the lowest that I've ever measured in the full data set, and this is for all species, is a little bit less than 2%, and the highest is almost 22%. And then when we get down to the 2 to 4 centimeter depth, just go a little bit deeper in the soil. Now it is really uncommon. I don't think I've ever measured anything more than 9%, and most of the samples are going to be around 2, 3, 4%. And that's the same thing that you find at the 4 to 6 centimeter depth. And then I also make a calculation because we're measuring at multiple depths. We're measuring at 0 to 2, 2 to 4, and 4 to 6. So we're getting all of those depths, and from that we can adjust for the bulk density in each depth, and then we can combine those numbers and get a total organic material in that entire layer. And when we do that, this has gone up from 3.7% to 4.4% in the top 6 centimeter layer. So that is a useful number. And I also report on these reports, I also report what it would be on a 2-inch depth. And we can do that through a little bit of calculating that I do, because when Dr. Caro did so much research on this about 25 years ago, he was reporting depths at a 2-inch depth. So to compare to Dr. Caro's number and to compare to Dr. Caro's recommendation that you don't exceed 4% organic matter in the top 2 inches, I also report that number. So the most recent number here for Imaginary Hills Country Club in December of 2022 was 4.8%, and it ranged from 4.2% to 5.2% for the different greens that were tested. So the average there, the average that's shown on the chart is the full 6 centimeter depth. That's 4.4%. But if we express that and calculate it what it would be on a 2-inch depth, that would be 4.8%. So now we can compare to what Dr. Caro's recommendation was. And now all of this stuff is new. And so this is just a data table where we show all of the clients' data at the different depths. So we've got the sampling date, we've got the depths, and we have the minimum value that was tested because people are testing multiple greens, and we have the average value, the mean value, and we have the maximum value. So I have some clients where this data goes back 7 years for this particular test. For the soil nutrients, ATC also does soil nutrient testing, and for that we have data that's going back almost 20 years for some of our long-term clients. But for the OM246, we didn't start doing this until 2017. So the longest time series we have for OM246 is 7 years. So when you do that, that type of table almost covers this entire page. So we can look at the OM2. And it's interesting because you can start, for example, at the OM2 at the first testing and just kind of go up, and you can see here it's gone 6.1 to 7.8. We saw that on the chart earlier. Here it is in table form, and you can also just kind of see these numbers. That's not terribly exciting, but it's another way to have the data presented. Here's what I think is exciting. I like the information in table 2, and I've always had access to this, and I kind of look at it as I'm generating the reports, and it's just been kind of stuck on my computer, and I couldn't, well, I knew that I could put this into the report, but it took a bit of coding time, and finally I was able to do that coding time and make a way to generate these tables. So now I make this table new every time I generate the report. So at the time this one was generated on April 23rd of 2023, this was based on 1,767 OM246 measurements from putting greens. So this is what's in the ATC database, and then this is showing for every species. And I want to point out something that is, well, I don't know. Maybe it will be interesting to you. It's interesting to me because I think that this is quite accurate. It's interesting, and it's using the power of statistics and data analysis and statistical models to use the data from the entire data set to provide even more information about the samples from any particular testing event. There are 7 species. There are 7 different species of grass in the data set right now. So we've got bent poa, bent grass, Bermuda grass, fine fescue, Poa annua, seashore paspalum, and zoysia or Kori putting greens. There are other grasses that are used on putting greens, such as Digitaria didactyla, which is Serangoon grass, maybe a few others. I don't really think of any off the top of my head that are very common, but there's certainly Serangoon grass, and I don't have any data for Serangoon grass. So if we look at all, the all row shows not only what the minimum and the averages are and the maximum is for all the grass species combined here, but it also would give me the expected values if I was going to go sample, for example, a Serangoon grass green, and then I would expect that it probably is not going to be less than 1.6% organic material in the top 2 centimeters. It's probably not going to exceed 21.9% in the at the high end, and I would guess that the average might be around 7%. I guess, because I don't have any other information. But here's the part that is interesting. The minimum column here is the actual minimum that I've measured. So when I get a new minimum, then this will update. And the maximum is from this data set of 1,767 measurements so far. The maximum value is the actual measured maximum value. So the highest that I've ever measured on a golf course putting green was 21.9% in the top 2 centimeters. For Bermuda grass, the highest I've ever measured is 20.8%. For creeping bent grass, the highest I've ever measured on a putting green is 13.5%, and so on. So that gives some extreme values, the extreme levels, and I think it might be interesting for you. No matter what kind of grass you're growing, you might be curious about what some other grasses are, and so I wanted to provide that. But the Q1, the Q2, and the Q3 are not, they're not showing the actual quantile. So Q1 stands for the 25th quantile. That is 25% of the values are below that and 75% of the values are above it. Q2 is the 50% mark. So half the values are below, half the values are above, and that is also the median. And the 75th quartile is shown as the Q3, and that has 75% of the values below that value and 25% of the values above it. These are actually, they're based on the real measurements. They're based on the real measurements, but they are generated and shown in this report from the output of a generative Bayesian model that incorporates data from all of the different species. Because some of the species I don't have so many measurements, specifically for fine fescue. For fine fescue, I have only measured from 2 different golf courses, and I think there's only like 13 samples from fine fescue greens in my database. So you will notice something very interesting, that the minimum value is 4.1. Okay, that makes sense. The Q1, the 25th percentile, is 4.3 for fine fescue. That makes sense. It's higher than the minimum. 4.8 is the median. That makes sense. It's higher than the Q1, the 25th percentile. The third quartile, the 75% level, is at 5.3. That makes sense. And the maximum is 5.5. Okay, that's a pretty narrow range though. And the 5.3, the third quartile, is pretty close to the maximum. If we jump down now to the OM4, you're going to see something that doesn't make sense now for fine fescue. But I want to explain how this is going to change and how I think that this is actually a really good thing, and it's so cool, the type of statistical model that is being used here. So for OM4, that is the 2 to 4 centimeter depth. If we look at fine fescue, the minimum measured is 1.1, the maximum measured is 4.4, but this table is showing that the third quartile, the Q3, is 4.5. So this model is expecting that for fine fescue greens, 75% of the greens will test at 4.5 or below, and 25% of the greens will test above 4.5. But the highest that I've ever actually measured is 4.4. So how can the third quartile be higher than the maximum I've ever measured? Well, that is where the model comes in. This is incorporating partial pooling of information from the other species, because the bent POA samples come from golf course putting greens. The creeping bentgrass samples come from golf course putting greens. The Bermuda grass samples come from golf course putting greens. And all of these greens are managed in a way to produce a very good putting surface, and they are all living plants growing in the soil, being maintained as golf course putting greens. So what this does is, how to explain it? I guess we can expect that there's a certain variability in the way that there should be total organic material that is not completely unique to bentgrass. Right? It's not like a creeping bentgrass green would have a very unique way of having organic material distributed on different sections of the green and then from one green to another across a property. There's some kind of expected variation that goes just from being a golf course putting green that's not specific to species. So that's where this model is generating data based on what the actual measurements have been, and from that we come up with, in all of these other cases, for all of the other grasses, the 25th percentile and the 75th percentile are inside of the minimum and maximum values that have actually been measured. But because the fine fescue data that I have is from such a narrow range, this model is telling me that my range is too narrow. This model is telling me that if we would go sample more fine fescue putting greens, there would be a wider range of values. And I'm sure if you have fine fescue putting greens, you must have measured some that are 6 or 7% total organic material, or 8%, which would make sense. And that's why I'm so glad that this model is showing a 75th percentile that doesn't actually match my data. It matches what the model expects reality to be based on the more than 1,000 other samples that have been collected from other grass species. So I think that is absolutely fascinating, and I'm so glad to be able to share that information with you. And hopefully this year, in 2023, we'll get a few more fescue samples into the database. I don't think it will take very many. Seashore paspalum, for example, we don't have a huge number of data points either, and but it's a little bit more than fine fescue. And Seashore paspalum certainly fits within the minimum and maximum values. But the fine fescue data I have doesn't yet. But we'll get a little bit more fine fescue data, and then that is going to fit within the minimum and maximum also. There are a total of 4 tables that I've added in the code to show in these reports. And the third table jumps right to those layers. So now it's showing the combined data from the 0 to 2, the 0 to 4, and the 0 to 2, the 2 to 4, and the 4 to 6 centimeter depth combined into a 0 to 6 centimeter depth. And now we can see in this table that the total organic material in that layer is at this level. So if you want to know, not at the specific layers, but adjusted for the bulk density in each layer and what the organic material is in the entire layer, now you can get that from table 3. And then you can go also and check what's normal. In table 4, you can check what's normal for these entire layers for the different grass species. And as with the information I showed in table 2, at the specific depths, the minimum is the actual measured value, the maximum is the actual maximum measured value for each species, and the Q1, the Q2, and the Q3 are the results of that model. And let's see, how does fine fescue look now? Yep, so with fine fescue, you can see again, the 2.2 as a minimum is the lowest I've actually measured. The 3.9% as a maximum in the 0 to 6 centimeter depth is the highest that I've ever measured. But this model is predicting that the 75th percentile for fine fescue would be 4.1. So that's based on all of the data that I have, and it's saying the way that this works in the Bayesian analysis is I've written a model that says that the organic matter is based on an overall mean plus an effective species and a different variability for each species. And then I feed that data into the model, and then the computer says if that model is true, if that is the way that the organic matter is distributed, if it depends on species and if there's a different variability from species to species, then given the data that you've collected and given the data that have been fed into the model so far, these are the highest probabilities for what the results would be. So this is something that we can predict what a Serangoon grass green would be, and we can also make some predictions about what fescue would be, even though I only have a limited amount of fescue in the database. So this is something new on the ATC OM246 soil test reports, and I wanted to share that with you as soon as possible so that anybody who gets some reports coming up in the next month or two will perhaps have a preview of what they're going to be looking at. And if you're not going to test again until the autumn, then well, you'll have that to look forward to also. And if you want me to generate one of these new reports, it's pretty easy if you're one of our existing soil testing clients. So if you're watching this, if that looks like something that you would like to see and you would like your most recent report to be updated, let me know, and I will get that run for you. And if you have any questions about OM246 testing and about what this is all about, I'm going to ask you to go to the AsianTurfgrass.com website, and you can find at the top of the website in the menu, you will find a soil testing tab, I think. Why don't I bring that up? Let's see. I'll bring up the, yep, soil tests. So I'll share this. So on the ATC website, if you go to the menu at the top, and if you're looking at this on the mobile, one of my recent videos, I called it a ladder menu. I think it might also be called a sandwich menu. So if it looks like this, then you can click. This is how it would look on mobile. You click on that, you can expand it, go down to soil tests, and you can see MLSN, OM246, soil tests, and other lab services. If you click on OM246, you can find out all about this. You can see sampling instructions. You could see sample report charts. That's going to get updated now eventually with not only the report charts, but also some of those tables. And you can click on the OM246 tab, and that gives you a tag about OM246 and all kinds of information about soil sampling and interpretation questions and all kinds of things that you can use OM246 for. And that is what OM246 is all about, and it can be really useful for helping to apply just the right amount of sand. And if you're not applying enough, that is going to tell you that you need to apply some more, and it's going to give you an indication of how much more you need to apply. And if you already are applying enough, then it's going to confirm that for you. So it turns out to be a really useful type of test. All right, that is all for now. I will put this in the OM246 playlist on the YouTube channel. And if you're not subscribed yet and you find this type of information useful and interesting, and you want to make sure that you get all of the new videos as they're released, make sure that you subscribe to the channel and click the bell to get notifications. If you do that, then you will make sure that you don't miss any of the upcoming information about turfgrass management and soil testing and best practices for managing grass all around the world. Thanks for watching.